So looking at number 30, we want to get our trig function all by itself. So what would we need to do first? Subtract 1. So square root 2 times sine of x is equal to negative 1. What would we do next? Awesome. Divide by square root 2. So sine of x is equal to negative 1 over square root 2. Now there was some questions like this on the homework, where if we look at our unit circle, sine tells us to look at what? The y. Do we have any y values on the unit circle that are negative 1 over square root 2? No, but we have something similar to it, looking at our unit circle. What's similar to that? What else here has a square root 2? .45 degrees. It looks kind of the same, but it's a little bit different. It has the square root 2 over 2. On the unit circle, it rationalized it. So here, if we rationalize this, we're going to multiply the top and the bottom by square root 2. So we get negative square root 2 over 2. Now, is this on the unit circle? Yes. So you don't have to rationalize, but if it gives it to you with 1 over square root 2, you should rationalize because that's how you're going to find it on the unit circle. So it doesn't really matter in your overall answer because your answer is going to be what x is equal to, or theta, what theta is equal to, the angle. But you want to rationalize in order to find it on the unit circle. So where is y negative square root 2 over 2 on our unit circle? 225, perfect. So that would be 5 pi over 4. Where else? And 315, awesome. That is y negative square root 2 over 2. So 7 pi over 4. So here x is equal to 5 pi over 4 and 7 pi over 4. If you guys want to, this unit circle, when you zoom in, it's pretty blurry. I don't know if it is on Notability for you too, but you could always just Google a different unit circle and put it in there. On the test, this will be given to you. Well, the unit circle minus the tangent part. So you guys need to know how to find the y over x for the tangent. So you'll need to know that one. All right, let's do one more. Let's do secant on the bottom. So the first one in red on the bottom. What should we do first here? How are we going to have to solve? If we have secant squared minus secant. Awesome. We're going to need to factor, so we want it to be equal to 0. So we're going to subtract 2 to move it to the other side. So secant squared theta minus secant theta minus 2 is equal to 0. Now let's factor. What are two factors of negative 2 that add to negative 1? Negative 2 and 1. So secant minus 2 and secant plus 1. So next we set both of them equal to 0 and solve. So secant is equal to positive 2 and secant is equal to negative 1. Any questions so far? So now secant is not one of the ones that we're used to on our unit circle. It's not one of the main 3. What does secant go with? Cosine. So we know that we can flip secant to be cosine, but that means we also have to flip the number. So we just make it 1 over whatever the number is, so 1 over 2. Let's do the same thing for our other little equation here. If we flip secant to be cosine, then we also have to flip the number to be negative 1 over 1, or 1 over negative 1, which is still just negative 1. So when we flip it, it doesn't change. So just make it 1 over whatever the number it gives you when you flip it. Now cosine tells us that we have to look for what? x. We want to see where our x on the unit circle is 1/2. So let's go back up to our unit circle. Where is x 1/2? 60 degrees, so that would be pi over 3. Where else? 300 degrees, so 5 pi over 3. So pi over 3 and 5 pi over 3 are going to be 2 of our answers. And then we want to do the same thing for when cosine's equal to -1. So that tells us we have to look at the x value, where x value is -1. Where on our unit circle is our x value -1? 180. Anywhere else? Nope, that's it. So just pi. Remember, your answers here have to be in the radians. So our answer would be pi. So these are our 3 answers. All right, let's take a look at 37. So we want to get our trig function all by itself. So what would we need to do first? Subtract square root 3. So tangent x is equal to negative square root 3. Tangent tells us we have to look for what? Y over x. So we're going to go to our unit circle and look to see where y over x is negative square root 3. So on the test, it's not going to give you the tangent ones here. No, wait these out so we don't have them. But you will have to figure them out. Or you could just memorize. When you do this enough, it starts to get repetitive. So you could just memorize. The first one is going to be 1 over square root 3. If you don't know that, do y over x. 1/2 over square root 3 over 2. Keep, change, flip. So the 2's cancel. This would be 1 over square root 3. What is it that we're looking for? Was it just square root 3? Negative square root 3? Yeah. So it's not this one. The next one, when you do square root 2 over 2 over square root 2 over 2, and divide the same thing by itself, it simplifies to 1. So pi over 4 is just 1. And then the third one, you can do square root 3 over 2 over 1/2. Keep, change, flip. This would be square root 3. So we're looking for square root 3, which would be the pi over 3. However, we're looking for negative square root 3. So which 2 angles would give us negative square root 3? You said 120 and 300. Perfect. Awesome. Remember, it's always going to be the ones with the same denominator, and the ones opposite of each other are going to be the ones that are the same sign. So because we found positive square root 3 at pi over 3, the one opposite of that is also positive. But then the ones with the same denominator are going to be negative, the other 2 that are opposite of each other. So we have 2 pi over 3 and 5 pi over 3. So x is equal to 2 pi over 3 and 5 pi over 3. Let's look at 42. So here, when we have different trig functions and one of them is squared, you always want to think, can I take out a GCF? Do these have 2 terms that have a common factor that I could take out? So there was one in the notes that's a good one to practice that had a GCF that we could just take out. But here we don't have a GCF. So we're going to have to change sine squared to be in terms of cosine, so then we can factor it. So we're going to use our trig identity. So our trig identity that involves sine and cosine is sine squared plus cosine squared is equal to 1. So sine squared would be equal to 1 minus cosine squared when we move the cosine to the other side. So we're going to take 1 minus cosine squared and plug that into the sine squared. So we have 2 times 1 minus cosine squared is equal to 2 plus cosine. So we see that we have a cosine and a cosine squared, so we know that we're going to have to factor. So we want to get everything on one side, so it's equal to 0. So what would I do first? Distribute the 2. Perfect. So 2 minus 2 cosine squared is equal to 2 plus cosine. Let's subtract 2 to move it to the other side and subtract cosine. Can I combine cosine squared and cosine? No, they are not like terms. It's like saying x squared minus x. Can't do that. But 2 minus 2 would be 0, so that cancels. So I have negative 2 cosine squared minus cosine is equal to 0. What could we do next? Take out the GCF. We said we were going to have to factor. Here we only have 2 terms now, so we're going to factor by taking out the GCF. So our GCF would be negative cosine, and we're left with 2 cosine minus plus 1, because we took out a negative cosine. You could just take out cosine, and you'll end up with the same thing. What would we do next? Set them equal to 0. So negative cosine x is equal to 0. When we divide by negative 1, it's the same as cosine is equal to 0. And then with our other one, we have 2 cosine x plus 1 is equal to 0. We need to subtract 1 and divide by 2. So cosine is equal to negative 1/2. Everybody with me so far? Cosine tells us we have to look for what? The x value. We want to see what x value on our unit circle is 0. Where is our x value on the unit circle 0? Where would that be? At 90. Perfect. Our x is 0 at 90. So that would be pi over 2. And our x is 0 at 270, 3 pi over 2. So pi over 2 and 3 pi over 2. And then same thing with the other one. We want to see where our x value is negative 1/2. So we're going to go back to our unit circle, look at our x values. Where's our x value negative 1/2? 120, so 2 pi over 3. Anywhere else? 240, so 4 pi over 3. 2 pi over 3 and 4 pi over 3. Right, so there's one like this from the notes. If it wasn't just like this, it was kind of similar, but I think this is good to practice. What would we do to solve here? Why would we want to take out cosine x? It's a GCF. We want to factor it, so we're going to take out the GCF. So we're going to take out a cosine x. When we divide both of these by cosine x, what are we left with? Sine of x plus 1 is equal to 0. So from here, we can set both of them equal to 0. So cosine x is equal to 0. Sine x plus 1 is equal to 0. I'm going to solve the sine one because we have to subtract 1 to move it to the other side. So we get sine all by itself. So sine of x is equal to negative 1. Now let's look at our unit circle. Cosine tells us we have to look for what? The x value. We want to see where do we have our x value of 0. Where would that be? $90 and 270, so pi over 2 and 3 pi over 2. So x is equal to pi over 2 and 3 pi over 2. And then we want to do the same thing for sine. Sine tells us we have to look at what value? the y value. Where is our y value on the unit circle? -1. 270. So that, again, would be 3 pi over 2. So you don't have to list it again, but it's already on our list here. 3 pi over 2. So these would be our two answers. Let's do 61. One of our multiple angles. So cosine's already isolated here. So cosine tells us we have to look at what value on our unit circle? The x. Where is our x value? 0. So pi over 2 and 3 pi over 2. So instead of it just being x equals, we have x over 4 equals pi over 2, and x over 4 is equal to 3 pi over 2. Now what would the last step be to solve here? Multiply both sides by 4. Awesome. So here we get 4 pi over 2, which simplifies to 2 pi. And the second one we multiply by 4. So this would be 12 pi over 2, which simplifies to 6 pi. So these would be our two answers. All right, let's also do the cotangent one on the bottom. So we want to isolate our trig function, so we can add 1 to move it to the other side. 3 cotangent squared is equal to 1, and divide by 3. So cotangent squared is equal to 1 over 3. What would we need to do next? Square root both sides. So cotangent is equal to, what do we have to remember when we take the square root of both sides? Plus or minus. What's the square root of 1? 1. And square root of 3 would just be square root of 3. So you have plus or minus 1 over square root of 3. Now cotangent isn't one of our 3 main trig functions, so what would we have to do? Take the reciprocal. So we're going to flip cotangent, and we're going to flip 1 over square root 3. So cotangent flips to be tangent. And then this would be plus or minus. We flip it, so it would be square root 3 over 1, or just square root 3. So when you have one of your reciprocal functions, just flip it, but you have to flip the number too. So now let's look to see where tangent is positive or negative square root 3. So let's go to our unit circle. We already found our first quadrant tangents. So what would be the first quadrant? What would be our answer? Pi over 3, because that gave us square root 3. Now we're looking for positive and negative square root 3. So where else would we have? 2 pi over 3. Where else? 4 pi over 3 and 5 pi over 3. Awesome. All the ones that have the 3 in the denominator, because this would give us negative square root 3. Down here we'd have positive square root 3, and then on the fourth quadrant we'd have negative square root 3. So pi over 3, 2 pi over 3, 4 pi over 3, and 5 pi over 3. X is equal to pi over 3, 2 pi over 3, 4 pi over 3, and 5 pi over 3. So you want to add 1. So 4 cosine squared is equal to 1. What would we do next? Divide by 4. So cosine squared is equal to 1 over 4. Then what? Square root both sides. So it cancels. We have cosine x is equal to, what do we have to remember to put when we take the square root of both sides? Plus or minus. What's the square root of 1?
1.
And what's the square root of 4? So cosine tells us we have to look at what? The x value. We want to see where on the unit circle is our x value either positive 1/2 or negative 1/2. So let's see, 5 pi over 3. Yep, that works. 5 pi over 3, 2 pi over 3, where else? 4 pi over 3, and pi over 3. Awesome. All right, so let's look at 36. 36 is actually already factored for us. What can we do next? Just set them both equal to 0. So cosine x is equal to 0, and cosine x minus 1 is equal to 0. So let's solve the second one, and then we can look at our unit circle. So we're going to add 1 to move it to the other side. So cosine is equal to 1. Cosine tells us we have to look for what? The x value. Where on our unit circle is our x value? 0. 3 pi over 2, where else? And pi over 2. Awesome. So pi over 2 and 3 pi over 2. In order to do the same thing with our other little equation here, we want to see where our x value is 1 on the unit circle. Where is our x value 1? At 0. Awesome. So 0 would be an answer too. So these would be our 3 answers. We want to get our trig functions to be the same if we are going to factor. Sometimes you can take out the GCF without getting them to be the same, but here we don't have a GCF. So we need to change the sign squared. So anyone that's squared, you can change. You can't change cosine plus 1 because it's not cosine squared. So we're going to use our trig identity. We know that sine squared plus cosine squared is equal to 1. I can move the cosine squared. So sine squared is equal to 1 minus cosine squared. So I'm going to replace the sine squared with 1 minus cosine squared. So 1 minus cosine squared plus cosine x plus 1 is equal to 0. I can combine my like terms, so negative cosine squared plus cosine plus 2. So I had 1 plus 1. What can we do next? Factor. Before we factor, I like it when my leading coefficient's positive. So let's multiply everything by -1. Just so we can flip the signs. It'll make it a lot easier for us to factor. So we have a positive cosine squared minus cosine minus 2 is equal to 0. What are 2 factors of -2 that add to -1? -2 and +1. So this would factor into cosine minus 2 and cosine plus 1. What would we do next? Set them equal to 0. So we get cosine is equal to 2 and cosine is equal to -1. Cosine tells us we have to look at what on the unit circle? Do we have anywhere on the unit circle where our x value is 2? No. So that does not give us an answer. What about for -1? Do we have anywhere on the unit circle where x is -1? Where? Pi. So x is equal to pi. That would be our only answer. And also the trig identities of these. And the sum and difference formulas too. So these will be given to you. So let's look at 7. So here we have a multiple angle because we have 2 times x. You'll either see it as 2 times x or 2 times theta, whatever your variable is in the trig function. That we save for last. So we want to isolate our trig function. So what would we need to do first? Add 1. So 3 tangent squared of 2x is equal to 1. what would we do next? Divide by 3. So tangent squared 2x is equal to 1 over 3. What do we do next? Square root. Awesome. We want to get rid of that squared, so we're going to square root both sides, so it cancels out with the squared. So tangent of 2x is equal to, what do we have to remember to do when we take the square root of both sides? Plus or minus. Now we can simplify square root 1 over 3. What's the square root of 1? 1. And the square root of 3 would just be the square root of 3. So we have positive and negative 1 over square root 3. I'm going to put in a unit circle here so we can see it a little bit better. Now this is one that we used in the notes. So we already found what tangent is in our first quadrant. You won't be given the tangent part on the test, so you'll have to find it or just memorize that 30 degrees is 1 over square root 3. 45 degrees is 1. 60 degrees is square root 3. You can memorize these 3 and you know that the ones with the same denominators are going to be the same, just different values. So where is our y over x positive or negative 1 over square root 3? At 30, so that would be pi over 6. So because we have a multiple angle, this is what we did yesterday. We have to say 2x is equal to pi over 6. Where else? 150? Is that what you said? 150. Perfect. So we're looking at the ones with the same denominators. So since we had pi over 6, we also need 5 pi over 6. So 2x is equal to 5 pi over 6. Where else? 210. And where else? 330. So 7 pi over 6 and 11 pi over 6. So we need to say 2x is equal to 7 pi over 6. And 2x is equal to 11 pi over 6. Now with our multiple angles, what's our last step going to be here? Divide by 2. So when you have multiple angles, you always save that for the last step, the very last thing that we do. So we divide by 2. What's the same thing as dividing by 2? Multiplying by 1/2. So this would be pi over 12. If we multiply by 1/2 here, we get 5 pi over 12. Multiply by 1/2 on the next one, so 7 pi over 12. And then do the same thing on the last one, so we get 11 pi over 12. So these would be our 4 answers. So when you have a multiple angle, if you have something happening to the theta or happening to the x, save that for the very last step. You do everything else normally and do that last thing that you do. All right, let's do some simplifying. So this we did in the beginning of the chapter, 7.1. So might need to refresh our memories a little bit with the simplifying. So we want to use our trig identities to simplify as much as possible. So looking at number 1, how could I simplify? Awesome. We can change tangent to be sine over cosine. So we have sine of x over cosine of x over sine of x. What can we do next? Keep, change, flip. We have a fraction and a fraction. So the sign on the bottom, I'm going to make sine over 1. So when we flip it, it's going to flip to 1 over sine. Could I simplify this? The sign on top cancels out with the sign on the bottom. So we're left with 1 over cosine. Can we simplify this anymore? What's 1 over cosine? Secant. So our answer would be secant. On your test, you're also going to have verifying. So that would be the 7.1 practice on Canvas. So there's more verifying questions on that practice for you. And then also on the test, you're going to have the sum and difference problems. So The ones from the notes were pretty good. You'll have, I think there's 2 types of questions, where one you have to work it out and use the unit circle. The other one you just have to figure out which formula you're using. So look at the ones from the notes for these 2 if you want practice with those questions. So work on the review. If you have questions, ask me. Come tomorrow with questions, because tomorrow's going to be your official test review. So your identities are going to be given to you. So this box will be given. You will also be given the sum and difference formulas and the unit circle. So let's do number 2. What can we do first for number 2? So when simplifying, we may want to change everything to be in terms of sine and cosine. So cosine is good. Secant, we can change to be 1 over cosine. So now on top we have cosine theta times 1 over cosine theta over, we can just leave it as cotangent for now. We'll see, because we now have 2 cosines on the top. What's cosine times 1 over cosine? 1. It'd be cosine over cosine, which is 1. They cancel out when you have a cosine multiplied on the top and on the bottom. So now we have 1 over cotangent. What does 1 over cotangent change to? What's the reciprocal of cotangent? Tangent. So this would be tangent theta. All right, for 3, we have secant squared minus 1 over secant squared. Usually when you have one of your trig functions squared, especially when you're either adding or subtracting 1 to it, you're probably going to want to use your Pythagorean identities. So let's see if we can make one of our Pythagorean identities be secant squared minus 1. So looking at our Pythagorean identities, I'm going to go to the one that has secant. If I subtract 1 on both sides here, we have tangent squared is equal to secant squared minus 1. So I'm going to take the secant squared minus 1 from my equation and replace it with tangent squared. So going to number 3, I'm going to replace secant squared minus 1 and replace it with tangent squared. Any suggestions on what we could do next? Let's change everything to be in terms of sine and cosine. What would we change tangent squared to be? What's tangent in terms of sine and cosine? Awesome. So it'd be sine squared over cosine squared. Because it's tangent squared, we're using the tangents equal to sine over cosine, but we're just making everything squared here. And this is over. How can I change secant to be in terms of cosine? 1 over cosine squared. What do we do when we have a fraction and a fraction? Keep, change, flip. Change to multiplication, flip the bottom, so we get cosine squared over 1. What can we do next? Cosines cancel. Since we're multiplying a cosine squared on the top and on the bottom, they cancel. So we're just left with sine squared. And that would be our answer. Maya.
For the secant squared on the bottom, you could turn it to tangent plus 1.
You could, but then I don't know what you would do from there. So you could definitely change the secant squared on the bottom, but then you're kind of making more work for yourself. Another thing that you could do here is, because we just have that secant squared on the bottom, we can split this up to be secant squared over secant squared minus 1 over secant squared. So think about it when we're combining like terms with a common denominator, or when we're combining fractions and we have a common denominator, the denominator stays the same. So here I'm just doing the opposite. I'm splitting it up, but keeping the denominator the same in both of them. What's secant squared over secant squared? 1. And then minus, what's 1 over secant squared? What's the reciprocal of secant? Cosine, so that would be cosine squared. And what's 1 minus cosine squared? Sine squared. So you can do it however you want, just make sure you're doing it correctly. You're simplifying correctly. But there's more than one way to get the right answer for these questions. All right, let's take a look at 4. So we're simplifying here. We want to combine these just to be one thing. See if we can combine it together. What do we need to add fractions? A common denominator. So a couple different things we could do. We could find a common denominator. We could, usually when we have 1 minus sign, and it's not squared, we can't use our Pythagorean identities, but we could multiply by the conjugate here. So we did one of these in the notes where we had to multiply by the conjugate. So we're going to multiply the top and the bottom here by 1 plus sign. We'll see where that gets us. I'm not exactly sure what I'm doing yet, so I'm going to leave the top as just cosine times 1 plus sign. So I'm not going to distribute yet. I'm just going to leave it like this until I figure it out. Let's FOIL out the bottom. Since these are conjugates, you can do your conjugate shortcut, so it'd be 1 squared, which is 1, minus sine squared. Or you can FOIL it out. You'll see the outer and the inner cancel. Well, what's 1 minus sine squared? Cosine squared. So I'm going to change the 1 minus sine squared to be cosine squared. So I'm going to cancel it out here and change it to be cosine squared. What could I do next? Do we see anything that could cancel in our second fraction? Anything the same on the top and the bottom? Cosine. We've got a cosine on the top and 2 cosines on the bottom, so I can just take one of them away. So this would simplify to 1 plus sine over cosine. So, and then we're adding that to 1 minus sine over cosine. Yes. Thanks. Can we add them together now? Yeah, we have a common denominator, so let's add them. So when you add 2 fractions, if I had something like 1 over 2 plus 4 over 2, remember your denominator stays the same. This would be 5 over 2. So when we add these together, we add the numerator, so it'd be 1 minus sine plus 1 plus sine over cosine. We can combine our like terms on top. 1 plus 1 would be 2. Negative sine plus sine would cancel, so we're left with 2 over cosine. What goes with cosine? What's the reciprocal? Secant. So this would be 2 secant theta. So 7.1 extra practice is good to look at to practice these. It's essentially simplifying, but it tells you what your goal is. So remember, we start with the more complicated side, so you'd want to simplify the left side. So simplify it, work it out, and then you'll end up with cosine squared. So always simplify the more complicated side. And it tells you what your end result's going to be. This is good to just practice with your simplifying. That way you kind of know what answer you're trying to get Another good thing to practice if you need help still with these simplifying your trig functions would be looking at the homework, because the answers are posted to the homework too. So lots of options for you guys to practice. So here this was sum and difference was 7.2. So you'll have 2 questions from sum and difference. One of them will kind of be like one of these on this page. One will be from the other page. But here we want to write as one single trig function and find the exact answer. For number 3, we want to see which formula goes sine, cosine, and has a minus in the middle. Which formula goes sine, cosine, and has a minus? Sine s minus t. So we're going to use sine. The first numbers are s, the second numbers are t. So sine of 124 minus 34. So this would be sine of 90. So this is answering the first question. This is writing it as one single trig function. Second part of this question is to evaluate. So we're going to go to 90 degrees here. It gives us the theta. It gives us the angle. So we're going to go to 90 degrees and see what sine is going to be. Sine tells us we have to look at what? The y. So at 90 degrees, what's our y? 1. So this would be equal to 1. So this is the second part of the answer. Number 4, when you practice this, it should be a minus in the middle. The question was just written wrong, so it should be a minus. And then let's do one more. I'll call it number 1. Okay, let's say it asks for the sine of 165 degrees. So 165 is not on our unit circle. So we have to use our sum and difference formulas. Do we have 2 numbers on the unit circle that add to 165? Okay, that works. So we're going to call this sine of 135 plus 30. You could have also said 120 and 45. That would have worked too. So more than one right answer here. You'll end up with the same answer at the end. When we're doing sine and we're adding, now we're going to go look at our formulas. So we're going to use sine and the adding one. So that is sine of s times cosine of t. So our first number is going to be our s, the second one's our t. So sine of 135 plus, times cosine of 30 plus cosine of 135 times sine of 30. Now sine of 135, sine tells us we have to look for what? The y. So go to our unit circle at 135. So we're looking here. What is our y? Square root 2 over 2. Now let's go to cosine of 30. Cosine tells us we have to look for the x. So I'm going to go to my unit circle. At 30 degrees, what's my x value? Square root 3 over 2. So we're multiplying it by square root 3 over 2. Plus cosine tells us that we have to look at the x. So what is our x value at 135? Negative square root 2 over 2. And then sine tells us we look at the y. So what's our y value at 30? 1/2. So now we multiply and add them together. When we multiply straight across. What is square root 2 times square root 3? Square root 6. And 2 times 2 would be 4 plus negative square root 2 times 1 would be negative square root 2 over 2 times 2 would be 4. When we combine these together, we get square root 6 minus square root 2 over 4.